Welcome to the second part of the tutorial dealing with execution cycles. And in this part, as you can see right here, I've modified the original circuit, which you can see in part 1, which had an 80 mega running everything and carrying out the whole cycle of adding two values, A and B, and then storing it and everything that you can see in part 1. So this is part 2, and there's not a lot to explain in this second part, but we're just gonna carry out some instructions, some operations, but we're gonna do it all manually using this panel. I've added a few things from the original circuit. First of all, I removed the 80 mega and set this panel here, which I used from a previous project. But aside from that, I've added another register here, which is called register D, and I've added it because I wanted to show also how I can fetch a value from the memory and then place it back on the data bus and reuse it. That is one thing. Here I have an array of PNP transistors, which I had to use in order to get this type of memory to work in this sort of example. Aside from that, I also connected the data bus to the programmable pins of the binary counter so that I can, for example, fetch a value from the memory, and that value will refer to a different address in the memory, so we can also use values as reference to different memory addresses. But that's about it. I added a lot of references to ground, a lot of pull downs here, and that's because the 80 mega is gone. But that's what you need to do when you're just using all these TTL chips as they are. There's not a lot to explain about this circuit as far as what it does. I covered it in part 1, and if you're interested in learning how each one of these components work, then you have dedicated videos for the LS7373 transparent latches, which act as the registers, the full adder, the memory, the binary counter. Everything is mentioned in the first part, so I suggest you go and watch it. And again, in this part, we're just going to carry out some manual steps and see exactly how we go about it and how many steps we need to take. For example, if we want to just move a value to register A, so how many steps it will take, and all these steps will be part of a cycle, a machine cycle, a memory fetch cycle, and all of these, they're execution cycles where we're executing a command, and the cycle will carry out several steps in order to reach the result that we're looking for in the command. So that's it. Let's get started. I'm gonna turn off the lights so that we can get a better view here of the LEDs and everything that is happening. Before that, best that I cover this panel that I made. Again, I used it from a previous project, just added a few switches here, but this is the panel. Here we have 4 switches which control our data bus. We can set values to it. Now I'm just going to use it initially so that I can actually put on some values that I decide, but then from there we're just going to store it and fetch the values and reuse them in this circuit. Here we have 4 switches which are for the latch operation, for the 4 registers, the output switches for the 4 registers, the 2 switches which will control the memory, allow us to read, write, or not do anything. Here there is another switch which I will use to load a specific address into the binary counter that acts as our address bus, and this switch will raise the clock of the address bus so that this value can be used. And that's about it for the panel. Here we have 3 switches and they are not used. So that's it. Let's get started. Turning off the lights right now. And right now the circuit is not on. I'm going to turn it on. and you can see there is a LED indicator. So right now we have everything operating and turned on. So as I mentioned, first of all, in the video dealing with the memory, when we first turn the circuit on, the memory will receive all random values. And we're going to have a look at that. So I'm going to read the memory now. As you can see, our address bus is at address 0. And I'm going to read the memory. And we can see that we have this random value here in the memory. And as I go up in the address bus, we will see this value or some other value. And they're all just random. So right now I'm going through the whole address bus. And you saw that these are just random values here. We're back to 0. So first of all, I'm going to write all zeros in all the addresses. So right now I'm setting the memory for writing. So we have both the ME and WE of this 7489. They are at low. That means we're writing. And I'm going to go through the whole address bus from 0 to 15, and it's going to write all zeros. And now we're back to 0 on the address bus. So I'm going to just set the memory to no operation, and we're going to start. So now, as you can see, as I go through, if I read the memory, there is nothing that sits in it, and we can start with a clear memory. So first of all, just for example, I'm going to set the value 1 on the data bus. Here is the value 1, you can see it right there. And now I'm going to place the value 1 in register A. So I'm going to latch register A. Once I latched register A, I can lower the data bus. And if I raise A, then you can see that A has the value 1, and the full adder automatically adds 1 with 0 that sits on B, and we get here the result of 1. So I'm going to lower the output for register A, and now I'm going to set the value, let's say 2 on the data bus, and 2 we're going to store in register B. So I've latched register B, and I can lower the data bus at this point. If I raise just register B, again we have 0 on A and 2 on B, and we get the result of 2. So now I'm going to also raise the output for register A, and now A and B were added together, and we get the result of 3. Now I'm going to remove this value of 3 into register C right here. So I'm going to latch register C, and at this point, once I latched register C, I can lower the outputs for A and B. I can also delatch them, and if I raise register C, we can see that we have the result 3 back sitting on the data bus. And now we're going to write this result, this value 3, into the memory at address number 0. So I'm going to first read the memory, because this is something that happens automatically once you lower the first the ME pin on the memory. And when I lower also the WE pin, we can see that we've written 3 in address 0. I'm going to raise the WE pin again. So now we are reading what is inside this address. So we can lower the output of register C. We can also delatch it. And right now the value 3 is sitting in the memory at address 0. So at this point, I want to move the value 3 back on the data bus. So I'm going to latch register D, which receives whatever value comes from the memory. And at this point, I can raise the ME on the memory, so we're not reading it anymore, we're not carrying any operation with the memory, but the value is stored in register D. Once I raise register D, we have the value back on the data bus. So what we're going to do now is we're going to take this value and we're going to call the address from the memory on the address bus for the cell number 3. I'm going to load it. And right now, whatever sat on the data bus, I call that address to the from the address bus. I can now lower register D, the output of register D. I can also delatch it. And if I read the memory, we can see that we have nothing in cell number 3 on the memory, because we've cleared everything once I've started. You saw that. What we're going to do now is I'm going to set another value on the data bus, and let's say we're going to set 4, and I'm going to set that 4 in register A. So again, I'm going to latch register A. At this point I can lower the data bus. We have the value stored in register A, and what we're going to do now is I'm going to go back to address 0 on the address bus, and we're going to fetch the value that sits in address 0, which was 3 originally, and this 3 we're going to put in register B, and then we're going to add 3 plus 4. So first of all, I have my data bus all zeros, so I'm going to load this value. Our memory is sitting on read. I didn't set it back to high, so it automatically reads this value. We're going to move the 3 into register D. We're going to latch register D. At this point, we can release the memory. Then we can raise the outputs on register D. The value is back on the data bus, and now we're going to set it in register B. So we're going to latch B, and once we latched B, we can lower the outputs for register D, and we can delatch it. Now we're going to raise both outputs of A and B again. So here we have 4 on A, and here we have 3 on B, and we get the value 7. And 7, we're going to write it in address number 1. So I'm going to raise the address on the address bus. Here we have address 1. We're addressing the memory at cell 1. We're going to move this value again into register C by latching it. Once we latched it, we can release A and B, and also we can delatch them. And now we're going to raise the output for register C, and we're going to write the value 7 into address number 1 in the memory. So first we're reading the memory, we have nothing in it, and then we are writing it. Once we've written it, we can then release it. So we're reading it again, and at this point I can release register C, and I can delatch it. And you saw now that we carried out all these operations using this panel. So let's do some more. Let's first of all review what we have inside the memory. I have here all 0. I'm going to load address 0 to the memory. Address 0 has the value of 3 in it. Address 1 has the value of 7 in it. Address 2 doesn't have anything in it. 3 also, and so on. The rest of the memory is empty. So now let's take this value of 3, again put it inside register D. We're going to latch it, then we can release the memory, we can raise the output for D. We're going to move the value of D, which is 3, we're going to move it into the A register. We're going to latch it. Now we can release register D and also delatch it. And now we're going to go one higher in our address bus. We're going to read what is in the memory. We have here 7. So we're going to take the 7, again, latch register D, and then we can release the memory. Then we can raise register D. We have the value back on the data bus, and we're going to set this value inside a register B. We're going to latch it. We can release D again, so I'm going to release it. I can delatch it. Now I'm going to raise register A. We have here our original 3, and we can raise register B, and we have our original 7, and we get the value of 10. And we're going to store the 10 again in register C by latching it. We can now release registers A and B and also delatch them. And we're going to store this value in whatever cell that is going to be in address number 1. So let's read the memory, and you can see here we have address number 7. We're going to move this again into D by latching it, release the memory, raise D, and now we're going to call address number 7 on the data bus. So now we called address number 7. At this point we can release register D, and we can delatch it, and now we can raise register C, which still holds the value of 10 that we added earlier. Here is the value 10, and we're going to write it in address 7. So right now we're reading what is in address 7. There is nothing. We're writing it. Then we're going back to reading it, and we can now release register C. We can also delatch it, and we've written the value inside address 7, which we fetched from the value that's at in address number 1. So let's look at the memory again. From the beginning, we can load address 0, and let's see what the memory has stored in address 0. It has the original value of 3, which we've placed in the first cycle that we went through it. Address number 1 has the value of 7, which we used as a reference to store whatever value we added of these two. And if we go now through the memory, 2 has nothing, 3, 4, 5, 6, and 7 has the value of 10, which we added. So we did all that just by moving things from one side of the circuit to another side of the circuit. And this was basically the whole example to show you just the exact steps that I'm carrying through using this panel in order to move values around and call different addresses in the memory and add them. You can imagine that if I replace this full adder with an ALU, the ALU will allow me to add some more functions here on my panel, so I can now add and subtract, multiply, divide, and also do logic arithmetics with all the values that come here on this circuit, and store them wherever I like and fetch them later on. And this is basically the things that happen inside the CPU. This was the point of this whole tutorial, the two parts of it. Again, the first part will show you how everything is carried out automatically using a script inside an ATmega, and this part covered how we do all of this using this panel, so we can basically have a look at each step of that script and what happens. Now, when it comes to the execution cycles, if you look at an assembly command, which would say, let's say, move value into some register, for us it is a single command, but what we saw here in this example is that in order to execute that command, we are going through several steps, from raising one part, lowering another part, and slowly moving this value to where it should be. So what we're looking at, for example, move 1 into A is a single line, but it takes 4 or 5 steps, depending on the design of the system, to actually execute this command. So it will take 4 or 5 steps to carry out a single command. One important thing is that you can, as you can see here on this panel, I'm going to turn the lights back on. And as you can see on this panel, aside from the 4 switches that control the value that I can set on the data bus, all the rest of the switches, they're always at the on state, or let's say in a high state. And that's because some parts they're active high and some parts they're active low. In this circuit, most of the parts are active high because those are the parts that I have. But the idea is that you use both the high and the low states of the clock in order to carry out these operations, and that way you reach a certain efficiency. So you're not wasting the cycle, and you can basically do less steps in more steps in less times that you need to go through the clock cycle of on and off. And that is the idea. So systems would use, older systems that would use these parts, they would use both active high and both active low components to get that sort of efficiency. That's it. That was the whole tutorial, the whole explanation. If you wanna, if you have any questions about it, then feel free to leave it in the comments and I will do my best to answer. I will I added a schematic for the original circuit that had the 80 mega. I'm going to modify this schematic to also add how to do this whole setup using a control panel, just like this. Everything that I've added here, all the pull downs, the transistors, the PNP transistors here that need to convert the value that comes out of the memory, everything is going to be in a new schematic so that you can also build this example and show it and demonstrate it and whatever. That's it. I hope you like this second part tutorial, and just in general I hope you like my videos. If you like them and you're not subscribed yet, then please subscribe. And that's it. Thank you for watching, and I'll see you next time.